I welcome you all in this lecture on parameter estimation methods. Using simulations or in simulation when we are going to simulate a model, there may be instances when we do not have the values of the parameters. Okay. So, role of the parameter estimation is paramount in carrying out the simulation studies. So, in this lecture we will be looking at how we can estimate the parameters. Okay. Fine. So, mathematical models are the basis of simulators and theoretical analysis of dynamic system, or say as a control system when these models are used. And these models, as all of you know, could be in the form of say differential equations developed from the physical principle, okay, or from transfer function models, which can be regarded as a black box model which express the input output property of the system. Why black box model? Because we know only input output property of the system. Now, some of the parameters of the model can have unknown or uncertain values. Okay. Now, for example, a heat transfer coefficient in a thermal process or in the time the time constant in a transfer function model could be unknown to us, that is, we are not aware of the values of those parameters. So, we can try to estimate such parameters from measurements taken during experiments on the system, because estimation of these parameters are important. Until unless you have those parameters available to you, you cannot go for the simulation. So, this estimation of such parameters is possible through measurements taken during the experiments on the system. Okay. So, see, the thing is like this: we have a physical system, and on this physical system certain input signal is given and we get a certain output signal. Now, with the help of these input signal and output signal, we can have the parameter estimator for the mathematical model. Okay. And from here we can find out the model parameters. Okay. That is, the parameter vector can be identified. So, this is what we are going to see in this lecture, that how can we identify through this estimator for mathematical model by giving the input and output signal, how can we modify measure the model parameters. So, here in this lecture we will discuss the popular least square method, or in short what is called as LS method for the parameter estimation. Okay. And the least square method can be used for parameters estimation of both static model as well as the dynamic models of a given structure. So, what does the least, how does the least square method looks like? So, let us see that how we use the how we use the least square method for the estimation of the parameter. Okay. So, for this actually the standard regression model use, and we can assume a model as it is indicated here. We can assume a model, say y is equal to phi 1 theta 1, okay, plus phi 2 theta 2 and so on, plus phi n theta n. Alright. Now, here what we do, we segregate the phi's and we segregate the thetas. So, here I can write these phi's separately, phi 1, phi 2, phi n, okay, and I can write the thetas, that is theta 1, theta 2 and theta n. Now, here you see this model which we are looking at, here phi I is the regression variable which is known, that is it has got the known values, we know these phi's, okay. So, these phi's are known to us. Y is the observed variable, again this y is the observed variable and we know this variable, it is also known, and theta here is the unknown parameter vector and we will use the least square method to estimate these values of theta. So, these can be represented in short by psi and this in short can be represented by theta. Okay. So, the regression model is linear in the parameter vector theta, and that is why you see that we are able to sum up, do the summation, that is we can use the superposition theorem to do this summation. So, the regression model is linear in the parameter vector theta here. Okay. So, in short I can write this y as say phi and theta. Okay. Now, let us assume that we have m corresponding values of y and phi. Okay. Theta I am interested in finding it out. Okay. So, this theta is, as I said, this theta is unknown to me and I know these values of y and phi and this theta is not known to me. Okay. So, we assume that we have m corresponding values of y and phi, then we can write the m expressions like this. Okay. So, if we have that m, these y's are available to us. So, my expressions could be as it is written there. Okay. So, my expression could be y1 is equal to say phi 1 1 theta 1 plus phi 1 2 theta 2 and so on plus phi 1 n theta n. Okay. So, this is 1 and we can have m such values. So, I can write y m is equal to phi, here there are since m values. So, this will be m1 theta 1 plus phi m2 theta 2, okay, and so on. So, I will have phi m n theta n. Okay. And again say I write these things in short as say phi 1 and this is theta and this I can write as say phi m and theta. Okay, because we have the m corresponding values of y and phi. So, I can write it like this. Okay. Now, what we do is that after doing this we write we express it in the matrix form. This can be expressed in the matrix form simply as you can see here, y1 you will have y2 and then finally ym, and then we will have a matrix and then we will have a vector, that is theta 1, theta 2 and theta n. Okay. And here what we will have is we will have psi 1 1 phi 1 1, phi 1 2 and phi 1 n. Okay. Likewise, we will have phi m1, phi m2, and we will have phi mn. Okay. So, this way we can write it, or in the short this can be written as what phi 1, say this row I am expressing by phi 1, then we will have another row expressed by phi 2, and then I am writing this by say phi m, and here I am writing this as theta 1, theta 2, and here theta n. Okay. So, this I am writing, and this component I am say writing in short as phi, and this as in short as theta. Okay. So, this can be written in a very compact form as y is equal to phi theta. So, we write y is equal to phi and theta, phi into theta. Now, here these are set of equations from which actually, as I said in the beginning itself, that here we assume that this y is known to us, phi is known to us, and we are interested in finding out this value of theta. Okay. And sorry. From here we will calculate or estimate a value of unknown theta using the least square method. So, let us see how we do it. Now, in the least square problem, what we do is that we define the error vector. Okay. So, the error vector can be defined, and this error vector will be basically y minus phi theta. So, we can arrange the error vector. So, E can be put as there are error vectors say E1, E2, and we will have EM. Since there are m rows, so we will have values up to EM, and this error vector can be written as say y1 minus say phi 1 theta. Remember here this phi 1 is a row vector, okay, and theta is a column vector. So, our multiplication here of this row and column vector is possible. Okay. So, we have a row vector, this psi 1 is a row vector and the theta is a column vector like this. Okay. So, we have the multiplication possible here. Alright. So, it is this, and then we will have here y2 minus psi 2 theta, and finally we will have y m minus psi m theta. Okay. So, this is there, or this E we can again put in short as say y minus this is phi into phi theta, y minus phi theta. So, this way we can write it. Now, the problem, as I told you, the problem is to calculate a value or an estimation of the unknown parameter vector theta, so that the following quadratic criteria function is minimized. That is what we are basically trying to do here, is that we want to find out the value of theta such that this summation of the squares of the error is actually minimized. Okay. So, first we can find out the function, which is to be minimized, that is v theta. Okay. And this is, as I said, we have the summation of the errors E1 square plus E2 square plus we are going to have EM square. Alright. Now, in a compact form this can be of course written as error vector transpose into error vector. Okay, so if you do this, multiply these two, then you will be getting the top row, that is summation of the squares. Now, in the short form, this can be written as y minus phi theta transpose into y minus phi theta. Okay. So, this is possible, and now when we take the transpose for this inside, what will happen is I will get y transpose, and here the transpose order will change. Okay. So, this will be minus theta transpose phi into y minus phi theta. So, this is what we get, and now we can do this multiplication. So, this will be y transpose y minus y transpose phi theta minus theta transpose phi y plus it will be theta transpose phi, okay, phi theta. Okay. So, that is there. So, this is what, oh sorry, here there is one small mistake. So, this is theta transpose, here will also be phi transpose. Okay. Only order is reversed. So, then when we multiply this, so we will have y transpose minus y transpose y minus y transpose phi theta minus theta transpose phi transpose y plus theta transpose phi theta. So, this is what you get. So, this is the same expression which is written over here in the slides. Okay. So, this is what we get. Now, what we actually want to do is that this v theta which we have, actually we will differentiate it with respect to theta and make that equal to 0. Okay. So, if I differentiate it with respect to theta here, then from here you can see there are terms theta transpose and theta. So, if I differentiate this term, then this is what I am going to get, that is 2 phi transpose phi theta, and these two term differentiation with respect to theta will lead me to minus 2 phi transpose y. Okay. So, this way we can do that, that is if I am differentiating this, then this since here we are going to get the square values will be here. Okay. So, I am getting this 2 because of differentiation here, and here since there are 2 terms and we are differentiating with respect to theta, we are going to get this value. Now, if you have understanding in differentiation in this form, okay, then you can take the scalar form, basically that is v theta was, if you remember, it was the summation of the errors square. So, this is actually E1 square, that is y1 minus phi 1 theta square. This is second error square term, y2 minus phi 2 theta square, and so on. Okay. Now, if I differentiate this with respect to theta, then naturally what you will be getting is 2 y1 minus phi 1 theta into minus phi 1, and 2 y2 minus phi 2 theta into minus phi 2, and so on. Okay. Now, you see that this minus and this term will be making it minus here. So, minus 2 y1 phi 1 I will be having plus this minus will be plus. So, it will be 2 phi 1 theta phi 1. Okay. So, this is basically what we are going to get. So, this form is similar to what you have seen here. Okay. So, here as you can see that there is a term corresponding to phi and theta. So, 2 phi and theta, and here is a term corresponding to 2 y and phi. So, 2 y and phi is there. So, if we equate it to 0, then this is what we are going to get. Okay. So, we will have the phi transpose phi theta is equal to phi transpose y. Remember, our interest is to find out the value of theta. Theta is unknown for us. So, now what I do is here that I multiply both sides, that is left hand side and right side of equation by inverse of this multiplication. So, here if I multiply by this, so phi transpose phi inverse into the same phi transpose phi into theta, and this will be equal to this. I am multiplying this to the left hand as well as to the right hand side. So, this I will be multiplying here to the right hand side also. So, this into phi transpose and y. Okay. And now you can see that this multiplication will actually lead to you an identification an identity matrix. So, this multiplication can be replaced by identity matrix. So, what I will be getting is the theta least square. Okay. So, this theta least square value will be phi transpose phi inverse, this multiplication inverse into phi transpose y. So, this is what I am going to get. So, this way we can find out the this theta ls value, and we can identify, or we can we can find out, or we can estimate the these values of the theta. Okay. So, by this I complete this lecture, and in next lecture we will take up 2 examples, and we will see that how can we use this method to estimate the unknown parameter in in an expression. Okay. Thank you.